All right, let's jump straight into this explainer. Imagine you just bought $1 million sports car, right? But then you realize you don't have a single paved road to drive it on. Well, that's exactly what's happening with AI and maintenance right now. Everyone wants the shiny new tools, but the truth is, most maintenance organizations aren't limited by a lack of AI. They're limited by terrible data quality. Before generative AI or machine learning can give you even an ounce of value, your data foundation has got to be rock solid.
So here's our roadmap for today's explainer. We'll start with the AI maintenance myth, look at the cost of bad data, walk through a 4-step AI readiness framework, tackle breaking down data silos, and finish up with building AI-ready organizations. Let's get into it. Section 1. The AI maintenance myth.
$12.9 million. That's a staggering number, isn't it? Vendors promise these incredible things: automated work planning, predictive maintenance, intelligent reliability forecasting. But the hard reality? The algorithms completely fail without structured data. In fact, research from Gartner shows that poor data quality costs the average organization a massive $12.9 million every single year. In a maintenance environment, that cost just hides in plain sight as inaccurate failure analysis, unreliable KPIs, and honestly, just poor asset lifecycle decisions. It really is a stark contrast when you think about it. On one side, you've got this sophisticated, futuristic AI promise, but on the exact opposite side, the mundane, messy reality. Filing cabinets and legacy databases filled with variant asset names across different plants, totally inconsistent coding, and just chaotic free-text work order descriptions. Bottom line, the algorithms are literally only as good as the data feeding them.
All right, moving on to Section 2, the cost of bad data.
Over the decades, maintenance teams accumulate massive technical debt. I mean, think about your own CMMS right now. Let's say one technician types a free text description like bearing failure, right? And another types failed bearing. Or maybe you have duplicate records for the exact same spare part. When that happens, pattern recognition completely breaks down. AI relies on consistency. If you feed it messy inputs, it's just going to spit out sophisticated, yet entirely inaccurate garbage.
Which brings us to Section 3, the AI readiness framework.
So here's the real kicker. Your first objective shouldn't actually be implementing AI at all. It absolutely has to be data integrity. Think of this standard operating procedure as the foundational architecture you need before you even think about touching advanced analytics. We're going to walk through these 4 key steps: establishing a taxonomy, normalizing codes, eliminating duplicates, and building semantic structures.
Step 1. Starting right at the foundation, you've got to establish a master asset taxonomy. Every single asset must follow standardized rules. We're talking uniform location structures, a clear parent-child asset hierarchy, and consistent classification. Actually, utilizing industry standards like ISO 1424 provides excellent guidance here. Because without a common taxonomy, AI just cannot reliably identify relationships between assets across your different facilities.
Step 2. We need to normalize those failure and maintenance codes. Building the walls of our framework means entirely eliminating those subjective, creative, free text entries. You know the ones, like machine made a funny noise. Those completely confuse algorithms. We need to shift to structured dropdowns and specific codes for failure modes, causes, effects, and corrective actions. A damage bearing needs to be logged the exact same way, every single time.
Okay, Step 3 is basically spring cleaning. Eliminate duplicates. Let me ask you, do you have duplicate spare parts in your system right now? What about retired equipment that's somehow still showing up in searches? Cleaning these out is absolutely mandatory, because when an AI encounters duplicate or obsolete records, it creates conflicting data sets, and that instantly tanks the AI's confidence levels in its own predictions.
And finally, Step 4. Honestly, this is where a lot of organizations stop, but it's where true AI readiness actually begins, building semantic data structures. This is the roof over our architecture. It's not just about hoarding data, right? It's about giving that data logical context so the AI understands exactly how a specific component relates to a specific maintenance action. Think of it this way. Instead of isolated records floating around in random tables, your information needs to become a connected mini-story. Let's say a pump contains a bearing, which experiences a specific failure mode, triggering a vibration alarm, which leads to a corrective action, and that consumes a specific spare part. By structuring it exactly like this, AI systems can finally understand contextual relationships rather than just processing random text. This is how algorithms actually learn to predict failures.
Section 4. Breaking down data silos.
Now, there's a hidden barrier we really need to talk about here.
A lot of leaders assume AI requires entirely new, wildly expensive software platforms. But the actual obstacle? It's fragmented information. Maintenance data is frequently scattered all over the place, across your CMMS, ERP systems, SCADA, and, inevitably some rogue spreadsheet databases. These disconnected silos actively prevent predictive models from working.
So what's the fix? API integration. Basically, installing digital plumbing. By enabling a bidirectional exchange of information, your operational data, financial data, and condition monitoring data finally connect to give the AI complete visibility. And the goal here isn't just connectivity for the fun of it. The goal is achieving what we call contextualized maintenance intelligence. That's the sweet spot where AI models finally get the visibility they need to generate genuinely useful recommendations.
All right, final stretch. Section 5, Building AI-Ready Organizations.
Let's pull all of this together. Look, artificial intelligence doesn't replace maintenance fundamentals. It simply exposes the weaknesses that have been hiding in your databases for decades. Before you even evaluate any shiny new AI initiative, managers must verify these specific categories on a CMMS data integrity checklist. And honestly, if you score below 80% here, you are going to struggle to achieve meaningful outcomes.
Now, a super common question we get about this is, well, how much data do I actually need? To pull back the curtain a bit, most predictive maintenance applications need at least 2 to 3 years of structured maintenance history to work reliably. You really do need that freshly structured, standardized history to train the models, which is exactly why starting the data standardization process today is so absolutely critical. Now, if you're looking for a way to actually implement this journey, the source material points to frameworks like Man-Win-Win as a great example. Systems that are positioned right between lightweight tools and highly complex enterprise systems can provide the structured hierarchies, API capabilities, and the vital data governance you need to build this AI-ready environment. So tomorrow morning, I want you to look past the marketing hype. Open up your CMMS and ask yourself, if an AI looked at this today, would it find intelligence or just noise? Is your maintenance data truly ready? If the answer is no, well, you now have the blueprint to fix it. Thanks for joining me on this explainer. Now go build that foundation.